setting my timer. Okay, thank you, Sim, and thanks everybody to be here, being here today. I am presenting today the paper titled Fuzzy Duck's Exact Air, which is the title of a third-year undergraduate architecture studio, modeled based on a long-time research and creative practice of my own. Is taught last spring by myself for the first time, is the last core studio required for a B.Arch 5-year program at our school. Followed the theme Systems and Atmospheres in the curriculum map, which essentially is looking at system integration in building design, and the paper particularly document the historical context and computational design method explored as part of the course, primarily looking at HVAC and building design to design architecture for air and for people. Modern architecture employed exact systems, calculated, programmed, and optimized to provide exact conditioned interiors. Most notable example including air exact and some translated in different words, but essentially offering optimized indoor humidified air at 18 degrees Celsius all seasons. We reconceptualize exact air as a critique to the environmental cost of cooling in the building industry, and we argue for the exactness of air to be understood and controlled in the relational system, one that not as a quantified output provided for inhabitants in space, but rather the specification of its dynamic attributes in the process of its creation and exchange. Which is also about accurately recording of air as a material moving through spaces modulated by natural or man-made systems, referencing some of the theoretical arguments in the field. For instance, Suzanne Wigel relates the inhaling and exhaling to global oxygen and carbon cycle. Giuliano Bruno stresses our responsibility of creating air for the climate, and Emmanuel Kosia points out we constantly modify the reality and the form of the environment as we exist in the space of breath. As we create domestic personal weather form mediated through cooling systems, we inevitably also contribute to the warming rate of the global climate. In that sense, contemporary living smokes, that's the argument we set up for the course, whether visible or not, literal or metaphorical, whether human breath and gas, or CPU and stove. And in the Fuzzy Duck's Exact Air work, we particularly explored digital and physical smoke as architectural material that informs design workflow and decisions. The methodology builds upon systematic construction of air, which I have been explored in my own work, as well as teaching for the past almost a decade. These include articulating geometric construction of heat using customized robotic devices, expanding the relation, making sure the video is running, expanding the relationship between points in space and the creation of lines, curves, surfaces, and volumes with the specificity of materiality of air, as well as digitally revisiting Murray's smoke machine experiments. Not sure if the video is somehow cropped, but you see kind of a portion of that appears, constructing air styles that appear as weaving, kneading, knotting, braiding patterns, playing with virtual material attributes and physics principles. Modeling and simulating air forms to understand the material behavior and topological form making, and at the same time as indicators of other spatial effects, such as force, movement, geometry, convection, and so on, produced by human inhabitants or by environmental constraints. These parallels with a series of pedagogical experiments. In 2019 Respirator Studio, we explore physical smoke and the sequence space formation through arrangements of surface colliders. In 2020, Filters Applied Studio, we explore digital hot air and the procedural workflow of drawing and simulating adaptable spatial systems through deconstructing filters and modulating the emergence of ephemeral hot air forms. And in Air Partitioning Studio, more recently in 2022, we studied the motion path through geometry as a way of actively participating in constructing the flux of spatial subdivision and reunion, turning the typical methods of material assembly into the play of velocity and vector. People's conception of air impact the way we deal with the built environment. And these explorations establish intuitive ways of working with air using emerging tools and workflows that are both scientifically accurate and aesthetically interesting and conceptually nuanced. For Fuzzy Duck's Exact Air Studio specifically, we expand the formal experiment of air to the consideration of designing ducts, air, and buildings as simultaneous process that is ambiguous and interchangeable. Looking at a long-standing debate and exploration in the field, some listed here, we consider the potential formal, social, public, economic, and technical functions of historical and contemporary examples, and fundamentally revisit the rift between the technical imperative and the symbolic building forms, which still dominate the architectural production these days, where the advancing and implementing systems of informal strategies for buildings at times becomes merely a symbol or design statement in the conventional design process. Instead, we argue that forms of smokes are fuzzy, therefore ducts are fuzzy, and we stress the necessity to appropriate new geometry, topology, and material, and to adapt to new design collaborative workflow where systems becomes atmospheres and mutates into architecture. Since modernism, I'm going to show the slides as a full version. Since modernism developed ventilation skills, today the intellectual thinking about ventilation still uses the 1960s logic. And that reflects in various current computational approaches, more traditionally listed here, such as CFD, FFD, or approximation or prediction-based model using deep learning. Not getting into the details of comparison now, right now, due to time, but overall, although current approaches present various strengths in analyzing and predicting airflow behavior at various scales, they fundamentally are deficient in terms of providing adequate informed design solutions at all design stages due to the required of embodied knowledge of the precisely defined design problems based on form and performance. And we also look at, in comparison to generative AI approach in terms of favoring the strategy of versioning, annotation, differences, co-creating with a user to produce multiple outputs as artifacts rather than a single decision. The challenges now are the field has been expanding and evolving so fast. So, but comparing to what we are right now, they still present. I mean, generative AI still present problematic understanding towards physics-based effect. Still cannot replace specialized multiphysics solutions such as CFD. A very quick comparison here. The right, this is based on runway, and there's a massive amount of available platform right now to actually create really powerful physics effects using generative AI tools. Here, runway ML as an example. On the left is Gen 2, and on the right was Gen 3 alpha image to video that I was finally able to really get some fine-tuned details of the stream and flow, but still it requires very sophisticated and hard to control process of prompting. So we instead looking for an open framework that is established as part of the course, looking at the challenge of a conventional way of approaching system and form based on the two objectives. One is to translate present analysis that is conventional system that is well established into new forms. Assisted by digital processes such as generative AI. And then we also would like to have a way to accurately assess, or at least scientifically accurate process of assessing some of these experiments. So we established a procedural pipeline that utilizes strengths across computational platforms instead of a singular tool. And I will share some of the examples as part of the presentation real quick. So these are some of the hybrid of curating images and drawings of the presence of systems, of buildings, as well as in nature, and then hybridized with Midjourney, animated using Runway, translated into volumetric conditions and simulated in Houdini, then materialized with off-the-shelf materials, products turning into building proposals. Example of hybridizing ducts utilizing some of the generative AI processes I just mentioned. The pixel intensity of runway videos are translated into voxel density and compiled into 3D fog volume. The parameters of morphing figures of the video, such as distorting range and speed, directly related to the final 3D form. Here is an example of the studio project where the student weighed various factors of the outcome, including cavities of the path of the flow, as well as the sectional transition to achieve a kind of an interesting form. Some of the drawings. Which was then turned into meshes and surfaces further operated upon and sliced along different axes to study its functionality interacting with smoke, a process oscillating between muted form of ducts and material properties of air using smoke simulations. Small prototypes and larger prototypes, and rather than using a one-to-one form translation, which is really, there's no point of translating air forms that was simulated into a physical environment. So we're looking at kind of a system approach. I know my time is up. And employ low-tech strategy and adaptable method to fabricate into larger solutions, which was locally sourced material and developed each project developed tectonics and frameworks in their own ways. Quickly running through some of the key discussions, including what is fog, which is representing medium flowing through spaces, and what is surface, which can be seen as forms of ducts. So I'm going through some of the. So just briefly showing a little bit of outcome of how these leads to a studio project. We repurposed a vacant lot in essentially a south and mid-south city in the U.S. Some of the final overview of the range of the project, and I'm just going to show two main categories. One is what we call not ducts, almost ducts, which can be which is essentially ambiguity about formal and organizational. During the process, ducts becoming fog, density becoming material, voids becoming solid, and system becomes atmosphere. So running through some of the quick showcase of the translation of geometry, but as well as scale, as just kind of a few of the, and I'll jump to the second one, and then I'll conclude. Workflow is quite preliminary due to the time constraint, so we tackled a lot of steps in, from the present analysis to the final architectural scenario. But fundamentally, what I want to argue here is that we cannot, if constructing air systematically and is essentially the same as architectural fundamental geometric articulation, if we cannot really think about constructing form and space without knowing how to put points in space and construct lines and curves, then we won't be able to make tangible environmental approach without understanding how the basic form of dynamic mediums, such as air, can be created systematically. So it is the most fundamental elements to work with, and we should radically rethink what our agencies are in bridging the gap between different fields with assistance from emerging tools.